Okay, so let's finish up our notes on forces and let's talk about some vocabulary terms and a couple of other ideas that are related to forces. So, a free fall. An example of a free fall would be if a bowling ball and a marble were dropped from the top of the building. What it's going to do is it's going to fall to the ground. So that's what we mean by a free fall. Now, their accelerations are going to be the same. All right, so the acceleration of the bowling ball and the marble are going to be the same because we know the acceleration due to gravity is 9.8 meters per second squared, which again, this is on your reference table. However, the force of gravity acting on the bowling ball is going to be greater because the bowling ball has a larger mass than the marble. Therefore, this larger mass is going to give the ball more inertia. So think back to our law, Newton's first law, all right? The law of inertia, and it is related to mass, okay? So this larger mass is going to give us more inertia. So more force is going to be needed in order to change the velocity. The marble has a smaller mass than the bowling ball, so its inertia is going to be less. All right, so let's take a look at this in terms of Newton's third law. The force of the bowling ball is based on its mass, and that is going to be equal to the force of the air pushing back up on the ball, and we call this air resistance. We're going to define air resistance in a moment. The only significant force acting on the bowling ball and the marble, therefore, is gravity, which is going to cause the acceleration to therefore be the same because, again, gravity is 9.8. So what is air resistance? We just used that vocabulary word. What does that mean? It is the force which opposes gravity. So if I take my pencil and I drop my pencil, it falls because of gravity, but on its way down, the air surrounding the pencil, that and the air specifically underneath, is pushing back up. All right, there's an air resistance there. So it's the force the air exerts on a moving object. And if the object is falling, the air resistance pushes up as gravity pulls down. So this basically is what we just talked about with the pencil. Now, let me make that look a little nicer because that doesn't really look like a word. It looks like chicken scratch. There we go. Pulls down, and that still looks like an A. There we go. Okay. So the amount of air resistance is going to depend on a couple of things. Speed, the velocity, size of the object, and the shape of the object. All right. And a larger area has a greater surface area, and therefore a greater amount of air resistance acting upon it. So let's take this idea of a free fall and air resistance. And what I'd like for you to do is I'd like for you to do the try this, pause this video and try this. I would like for you to take 2 sheets of paper, crumple one up and leave one uncrumpled. Keep them at the same height and drop them at the same time. What happens? Okay, so when you did that experiment, what happened? Which one hit the ground first? The crumpled up piece of paper or the paper that was flat? Now think about this. Why did that happen? Which one of those had a larger surface area? Therefore, more air resistance. Now the acceleration from this free fall, from them falling down, is going to be the same. However, they did not hit the floor at the same time. Why not? Because of air resistance and the surface area acting on those objects. So now I didn't give away the answer. I just gave away the explanation to the answer. So if you didn't actually pause this video and try it, please do so right now. Go ahead and try that.